Hello and welcome to TidyX episode 35. Alright, TidyX is a screencast where we go through and try to explain how our code works. My name is Ellis Hughes. I'm a statistical programmer. You can find me on Twitter at Ellis_Hughes.
And I'm Patrick Ward, and I do data analysis and sport. You can find me on Twitter at OSPPatrick. You can find Tidy Explained on Twitter at Tidy_Explained. Or you can send us an email with some thoughts, ideas, things that you might like to see at tidy.explained@gmail.com. So
Yes.
Today we're going shopping at Ikea.
Yes, we are. We're trying to figure out how to furnish my new house.
There you go. Yeah.
Yeah,
Nice.
so just got a new house, so super pumped about that. So I need to go to Ikea to figure out what to furnish it with because I have nothing.
Well, if there's one thing that you won't need, it's the little orange box of IKEA tools. I definitely have one of those that you can borrow, and you
Sounds
can ratchet
perfect.
and hammer to your heart's
And
content.
get
on
some
your
stuff
new-
done and work with the little IKEA tools that come with.
Yeah, that's right.
Perfect.
Yeah.
All right. But yeah, so the IKEA furniture data set is from Kaggle this week. And it's got a bunch of information about all the items that IKEA carries. So item ID, name, category, price. But they also have information about designer, depth, width, height. So just a bunch of pieces of information for people to do stuff with. A lot of people looked like they were doing like scatter plots. Some actually were just showing the items themselves, which kind of looked pretty cool. But one that Patrick and I thought was really interesting was from Henry Wakefield. And he did this plot, which we're looking at right now, which is showing the dimensions of the various categories of items that exist in the IKEA dataset. So he set the x-axis to be width, the y-axis to be height of that item, and then just basically used rectangles and drew them over each other so we could see how they all looked next to each other. So I thought this was really interesting.
I think it's there's a few things with this plot and with this data set. I think the first is there's no cleaning required, so it's a pretty clean data set, which is great. And the second is this plot is just nice. One, it's visually appealing with the IKEA colors, but I think what's nice about it is it's a plot that is really kind of cool for exploratory data analysis. Like it just kind of, you can put it together, you're looking at the dimensions of the furniture, and it just allows you to ask more questions that you might then drill into, a specific furniture grouping and find more information out about and things like that. So
Yeah.
I think that's kind of a cool thing.
Like you can look at chairs here, and a lot of them are kind of roughly around 100 centimeters. It looks like a good chunk of them are there, like between 75 and 100. And then there's one that's over 150. Why is that?
Well, that's the high back Dr. Evil chair from Austin Powers.
Yes. Yeah, and then you look at room dividers, and there's just like a consistent, like they're 75 centimeters and 100 centimeters and 125 centimeters tall, and then 180 centimeters tall. And that's just that's the sizes they have, and it's like, oh, okay, cool. So there's less design. I mean, there's probably a lot of design in it, but the size is rather consistent. Beds, you can see a good chunk of them are rather low, but then there's some probably ones with the headboards, tall headboards there, and so you can see those there. So I don't know, it's just a fun way to look at it.
Yeah.
And so we thought that everyone would be interested to learn how this was made. So I reached out to Henry. You can actually see the tweets right here. And he said, yeah, go for it. And so his code is available on GitHub. There's a link in his Twitter post. We'll, of course, also share the link. And so he took this code and copied it into our R session, which we have right here. And we'll step through it. Thankfully, it's a pretty straightforward one. So it'll be good, and we can kind of extrapolate a little bit. So the first things that he does is loads tidyverse and extra font. Tidyverse, of course, for data manipulation, extra font to bring in fonts for ggplot. He's setting his theme to be theme minimal, so he doesn't have to add that on. Once he creates the image, it'll automatically set that theme when he goes forward. All right, this piece, he is grabbing the data from the Tidy Tuesday GitHub repository. He's explicitly using read-R's read CSV. However, he has loaded tidyverse, so he doesn't have to do that, but this is still good practice. to very clearly define what you're using here. This CSV had an extra column on the left. It was like row number, something like that. So because it didn't have a column name, read CSV assigns it one, and in this case it used x1 to assign that. Then he does some very minor data cleanup to just help the plot out later on. He cleans up two categories that are rather long names. So the category of sideboards, buffets, and console tables, he's now simplified into sideboards. And so using this case when. So case when category is sideboards, buffets, console tables. He turns that just into the simple string of sideboards. Then when the category is chests of drawers and drawer units, let's simplify that just to drawer units because we can understand what that is. We don't need to have that extra information. Otherwise, leaves category exactly the same as it was. The next step is he removes any time when the category is cafe furniture. I'm not quite sure why this decision was made, but I'm assuming it was because the furniture kind of was all different shapes and sizes, and also when you look at the plot, it was a perfect square of 4 columns and I think 4 rows. With this extra category here, it kind of bumps it down to another row. So it might have been an
executive decision.
Yes.
Listen, one of the furniture categories needed to go, and it was cafe furniture.
This time it was.
For the sake of plot cleanliness.
Yes, exactly. Sometimes you have to make those decisions.
Listen, yeah, that's how it goes.
All right, Patrick, you want to take us through how the actual plot was made?
Yeah, let's do it. So we've got our IKEA data set. As I said from the outset, super clean data set, so nothing to really have to deal with on that front. So we're just going to take that IKEA data set. We're going to pipe it into our ggplot, which we've done a billion times on TidyX. And we have our defining our aesthetics. So this is a width and height type of plot. So we're plotting the dimensions with width on the x-axis, height on the y-axis, as your kind of minds would wrap around width and height. And he's going to use geom_rect. I don't think we've used geom_rect before, but it is it's a cool. There's a few of these kind of cool plots in ggplot. I think in the volleyball one we used geom area, which is also one that kind of can allow you to color in space, right? So geom_rect is a plotting function that takes an x-min and a y-min, which he's going to set at 0. So he always wants to have the plot begin at the bottom left base of the grid. And then he sets his x-max to be width. So that's going to be the width of each individual furniture item. And then the y-max to height, which is the max of each individual furniture item. And then he kind of styles it a little bit. So alpha 0.1 is the opaqueness of the coloring in of the rectangle. So he wants it to be a little more opaque because there's a lot of different furnitures that are being plotted over top of each other, as we saw. He's going to specify the color fill of that rectangle to be the IKEA yellow, and the color of the line around the rectangle to be the IKEA blue. So he specifies those with the corresponding hex colors. And then the size of the line of that rectangle, so the outer line of the box, he's setting to 1.2, so slightly bigger than the default of 1. And then he's going to define the parameters of his x and y axis scale. He always wants it to start at 0. Obviously, those were his x and y mins, and he always wants it to go to 200. So he wants consistency across all of the facet graphs. He's going to pass in his facets as categories. That's what we saw on the plot, which were the little titles over top of each picture. And he says, I want to have 4 columns. And that's how he gets that nice box type of thing, minusing the cafe furniture category. So now after that, the plot has been defined. It's literally styling everything together. So we've got our labs is going to tell us we want the title to be the many shapes of IKEA furniture. He sets his X title and his Y title, which are the width and height, and he specifies the units, which is also important, so sets it to centimeters. And then the caption, which we think is really important all the time, is just kind of explicitly stating the source. He gives himself some credit, which is always good. He has some GitHub information, some Twitter information, and even the date of when he created that plot. And then the theming. So he's going to just get rid of the legend because it's not telling us anything that we can't already see in the graph visually. So that's kind of nice to just remove the legend. It takes away the busyness. He set the theme to minimal. So he's just going to remove the panel. I think you could actually set the theme to, what is it? Theme to classic or something like that might actually do that automatically. But he removes the panel grid by saying element blank. He sets his strip text. So the strip text is the text of each facet title. So that's the title over top of the block, the pictures. So he's actually setting this to a specific size, and face bold is the face bold, like bold font. And then he's doing the same type of thing for the titles of the axes, and then the title of the plot, and then some or axis title, and then some information on the plot. So now he's just saying, okay, hjust 0.5 means I want it to be middle of the page. He sets the size to be relatively large so that it stands out. He sets it to bold, and then the family is the type of font that he would like to specify. I've never heard of that font before.
Yeah, I think that's through extra font.
Oh, okay, that's where it came. Okay, yeah, there you go. And then let's see, text element, text family. He wants to make sure that the text is consistent with the plot title, and then the plot caption, he sets the size of that, and the plot margin he sets in units of 1111 in centimeters. That's the units of the actual width and height of each of the facets. So let's go ahead and take a look.
Alrighty. And
there
shablam! There
nice
we go.
plot.
So it's exactly what we saw up on the Twitter. We've got all the different categories here listed out. We've got the room divider sidebar here. I'll just zoom because I think it looks a little bit nicer.
Yeah, there you go. That's cool.
Make it full screen for us. We've got these wardrobes here, so a chunk of them are because you can look, and the darker the yellow or the bolder the yellow, the more overlap there is. So the more common that size is. And so tables and desks tend to be these lower pieces here, but they might have upper cabinet areas down here. I don't know. I think it's just a fun way to look at all this.
Especially if you're shopping, you might be like, oh, I need a new table or desk, but I have these constraints within the room. Mm-hmm. So now I can really quickly be like, oh, let's go to the data set and find all tables and desks that are under 100 centimeters in width and maybe 50 centimeters in height, and that.
Mm-hmm. Do it better. Do it through our stats. Don't do it through IKEA's furniture search algorithm that they've got up there.
Yeah, exactly. You have to control. IKEA is it's a landmine. You walk in that store and there's so many
everything everywhere.
Yeah, I can't go in. It's too much for me.
It's too much. One quick note too is I did. He had a GG save at the very end of this, so it was a plus GG save. I just didn't want to have it run and then save it in the wrong directory. But after the plot is created, using GG save, setting the file name. So this is the actual file name of the PNG that gets created. He's setting the type. So this is what engine to be using when it's generating the image. This time he's using Cairo PNG, setting the height and width of the actual image to be 10. I think by default it goes to 10 inches, or the units as inches, and setting the DPI to be 180. So it has a lot of clarity in each thing there. And so that is how this plot was made. So
pretty cool.
Thank you so much, Henry, for letting us go through and explain how your code worked. I think everyone will find this very valuable.
Yeah.
All right. So we, as per usual, took this idea and ran with it. And we had a couple ideas throughout the week. We're trying to figure out, okay, how can we show data?
Yeah, two qualities, right?
Two qualities where it actually means something. You want to look at them together, and that total area beneath it actually means something. Yeah. It's not just, otherwise you do a scatter plot, right? Or a genome point, because why else would you do that sort of plot? Which is also why I thought that was a really interesting data viz. And so we were thinking, and one idea that I had, which is we're going to go through now, is looking at data around hikes. So where we can look at the actual elevation gain against the actual length, full length of the hike, and to kind of get us a grasp of like the effort involved essentially with those hikes. We thought that could be an interesting way. The data set will be available on our GitHub if you want to take that and run with it and have some fun with it.
Yeah.
And sorry, this is horribly, it's not even commented, so we're going to have to go through this.
Yes.
So let me quickly restart my R session so that I'm running on clean R. All right, so we're loading in the library rvest for web scraping, because as per usual, we're scraping from the web using tidyverse for the data manipulation. The library here so that I can set the file path easily, and then using ggplot to do the final data viz. Oh, and then I should also bring in plotly. I guess that's a spoiler, but whatever. Alrighty, so I've set this up so I don't need to run all of this while we're talking, because it does take a fair amount of time, but we will step through the code here. So the first thing I do is I like to set a file path to where if I'm going to be running a process that I know is going to take a long time, but I only need to run it once and once only, I like to set up, and I think I've talked about this in past episodes, I like to set up an if-else statement that'll check to see whether I have those results already existing. And so what I did here is I plan to save the data set as an RDS, which is an R data. I prefer RDS objects. Just know that you save RDS. It's good. So I set the path there, and then so now I've got
easy way to save a lot of data that's not like in CSV or something.
Exactly.
Like that.
It saves it as an R object.
Right.
And so now we've got this object hike data RDS, which is the file path to where I want the actual RDS to be saved. And so I do a quick check at the very beginning going, hey, computer, check to see whether that RDS exists or not. Because if it does, don't worry about running this code or the rest of this code. And in this case, it does exist because I have this negative here. I'll zoom in a little bit because I realized I'm a little zoomed out. This exclamation point means inverse the results. So we can just do file.exists. It does exist, so it's not going to run the rest of this code. We'll just kind of quickly step through it so you understand what's going on. So what I did is I scraped a bunch of data from the Washington Trails Association website. They've got this handy-dandy website here where you can go through and look up hikes in Washington State, which I think is a lot of fun. I've definitely enjoyed looking at what's available in the area. Living in Seattle and this area in general, outdoor activities are pretty common. People like doing them, and we have weather that usually supports us going out there during the summer where it's not 100 degrees. It's usually like the 80s and 70s, and so people do a lot of outdoor hiking around here and camping, and so this is a place you go to look at that. So started scraping this data set here. Thankfully they set it up so they've got this URL here, and I can just like iterate through this and it'll bring up the next 30 image or hikes right here. So I was able to set up a loop to go through that. So that's what we're going to do. So there were 129 pages of hike data that could be pulled here.
How did you find the final page?
So what I did was I looked at this and it said it loaded out to 129.
Oh, is there okay? Like, what if the only reason I ask is like, let's say we're on. Because we've done this before, right? Like, let's say we're on Basketball Reference and we're looking at every basketball player in a season, and maybe there's N number of pages. How would you set it to say, go through until you can't find any more pages? Keep running.
So what you're talking about is a while loop.
A while loop, exactly.
Yes, which we didn't have to do here, but what you could do is you'd basically go, okay, keep grabbing the next 30 of plots while there's data to pull.
Yes.
And as soon as there's no more data, kick out of this loop.
Which is super, and we haven't used while loops before.
It's not super common because usually I've found that while loops can be kind of dangerous.
Yeah, because you can get in trouble and then you have to just crash everything.
Exactly. We should probably show a while loop at some point.
Yeah, I think it would be
It's
good.
essentially like you set up a condition and set it to be true initially. And then do while condition. So while this is true.
Yep.
do the thing, right?
Correct.
And keep on doing it. And it's going to keep on doing that. But then you need to also have a check condition.
When to stop.
And then condition is results. So it'll keep on running until results returns false. And then it will stop executing that while loop.
Yeah.
And so, sorry, that's just a quick crash course in while loops. I've usually found that I can get away with for loops and predefine how far it's supposed to be looping, because very rarely do I not know when it needs to stop.
Right. One of the things so I've done this before, like I've scraped a whole bunch of basketball player efficiency ratings, and it was like seasons and seasons, and I didn't know where the last page was. So I literally would set a for loop and be like, okay, I'm going to go from 1 to 50,000, right? And just let it run and then see what it kicks out. And like, okay, there's some data still. What if I go to 55,000? Like a little bit of trial and error to figure out where the cutoff is, and then you're safe.
Yeah. But, I mean, that's another way to do it too.
Yeah.
So, no, it's all good. But yeah, so I knew there were pages 1 to 129.
Yep.
So I set that up. So then I set up this apply, which is very similar to a for loop, except it allows me to use a function instead of actually writing out all my code inside of a for loop. It's just a little bit cleaner way to do it, I've found. It's also it can be, or more often than not, it's faster than using a for loop, even though the structure is very similar, which is why I like doing it.
Yeah, for sure. And why the apply instead of map, let's say, this time?
No real reason. They're going to return I'm still kind of stuck in the base R things for looping and whatnot. Like I jump back and forth. I actually use map right here. So I can't really say there's a consistency to the way I do things. I wish I could. Yeah, but that's just kind of how mine works. So I know that there are pages 1 through 129, but as you see here, I subtract 1. And that's because if you look at the
0.
The thing here, and I go to 0.
Yeah.
Well, I want it to start at 0 because that is their zero-based counting, which is unusual to our people since we always use 1-based counting. So the first column is 1 in R. In a lot of other languages like Python it's 0-based. And so the first column is actually 0. It's really confusing to me. I'm sure there's reasons behind it. But, so it's 0-based here. So I want to be grabbing 30 pages, or the next 30 hikes every time. And so I need to subtract 1 so that it's 0-based. So I grab that. I have set up my URL here. And this is, so I figure out the start int. So where the first plot I want to be grabbing. So the first page is starts at 0. So 30 times 0 is 0. So it's going to create this URL and start at int 30 and show me the first 30 hikes. So from basically 0 to 29. I take that and I read that HTML in. And I do very similar scraping to last week's episode, 2 weeks episode.
2 weeks ago, maybe we did a bunch of.
So it's a very, very simple. So I grab these HTML nodes, search result item, and it's basically little blocks of the information that we see here. So each one of these is like a block of information, and now I'm going to loop over each one of those and grab the information out of it. Where I'm grabbing the name using HTML nodes. This is the class name, and pulling through that, and then HTML text just converts the actual text that would be shown.
So for more explicit explanation of all this stuff, I got it up here. It was episode 33 where we were scraping the beer and state maps.
There we go.
There it is.
But yeah, so sorry, I just don't want to spend a lot of time going through this because it's rather boring stuff, and this is just HTML web scraping stuff that we do.
And in episode 33, we actually do go through using the inspector element and how to find these things. So that would be a good one to review, because literally all of those nodes are pieces that come out in the inspector element once you right click on the page and you look at it and you scroll your mouse around and yada, yada, yada.
Yeah, so inspect there.
Yep.
Oh, there we go. So we can look. This is like what's telling the web page to look, and this is what the actual data that we're pulling through.
Yeah.
So yes, go to episode 33. Got a lot of great information there, and then I loop through all the I loop through all the items there, and then loop through all the pages, and then I bind them all together using bind rows because they're a list then, and it just creates this big old tibble of everything for me, and then I just save it as an RDS. But because I've run all this before and it takes like 15 minutes or so, we're not going to go through that. We're just going to pull. We're going to run that. I almost ran the loop again. We don't want that. And so now, rather than going through and rerunning everything, I'm reading that saved RDS that I had before, and I'm assigning it to the same object that I was outputting as before, which is this fun data set, which once again will be available on our repo. If you want to pull it down and start doing some data viz, I should reach out to Thomas Mock and ask him if he'd like this data as well. So then we take this hike data and do some cleanup. Patrick, do you want to take us through this?
Yeah, so a little bit of cleanup on the data because as you can see, there's a number of character columns in that tibble. There we go. Actually, they're all character columns.
It was easier.
Yeah, exactly. Even the ratings, which looks like a numeric value, and high point end gain. So a little bit of a cleanup through here. So mutate. So the first thing that we've got there is when we're going to create this variable called trip. And that's because in that length column, you can see that it's a numeric followed by a bunch of words. And that's just basically telling people, right? So like 12 miles round trip means you're going 6 out and 6 back. But then there's times where it might say like one way. So yeah, if you might go 7 miles one way, blah, 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 right? So it's just a little bit of cleanup here. So you're using the grepl function, which is a base R function. And so basically what you pass it is the string that you're interested in finding. So here we're interested in finding the word round trip within the column that's called length. And any time that we find that, we are going to assign that in this new column called trip. We're going to assign that the word round trip. And we do the same thing for one way. And we do the same thing for of trails, which I'm not sure exactly what.
Yeah, so there's some records in here that, let's do grepl or grep of trails. And let's set that to be pattern. And I am trying to outthink myself. Value equals true. There we go. So this is going to then find all the records where of trails show up and return the actual value, because here it returned the index. So like there's a couple of them where it's 3.0 miles of trails.
Oh, of trails. Okay.
And so it's considering this hike to be a series of a bunch of different hikes.
You have options.
Yeah. So like hike data, filter, or no, slice 61. So this is that first record there. So this is the select name, location, description. Let's leave description off. So this is the Brightwater Center Trail. It's in the Puget Sound and Islands, Seattle, Tacoma area.
Tacoma area. Okay, yeah. Interesting. Okay, cool. So after you create that column, then there's a bit of regex expressions going on here. So the length total column, if we were to look at that, it was a column that had like 3.5 miles of trails, right? And so you have to do a little bit of work because you want to extract out the actual numeric value, and then reflect it as a numeric value, right? So you're obviously within the as numeric function, you're passing in this G sub, which is helping you to find specific elements within that string. So you have the \\\, D plus dot. So you're looking for the value that is happening before the dot, right? The period.
So I'm grabbing
everything that's before the words.
Yes.
Yeah.
Literally, yeah. So thankfully, they formatted this in such a way that it always begun with
Yeah.
and miles that they had, and then
Right.
it had details about it in the very end.
Correct. Correct. So you're grabbing all of the words and then you're subbing in anytime, and that's what the dot and then the multiplication star means, right? Everything up to this point, up to the space or whatever, right? Yeah.
So it's basically this expression is going to grab the entire statement,
Yep.
but then keep only the digits.
Oh, that's it. Okay. I
That's
think isn't there a function that you could I think there's a function in like that just like will only extract numbers in string R, isn't it? I can't remember. I feel like there's one that would be just like literally pass it that string and it'll just give you. Maybe
I don't know.
maybe I'm
Maybe
wrong.
maybe somebody knows it in our viewership and can comment in the
Yeah,
comments.
yeah, that'd be great because I feel like I've used something like that before. But anyway, you're extracting out the number from the entire string, and then you're also doing a little bit of voodoo here. So if it's one way, you're ensuring that because you want this to be the total length. So if it's a one-way trip, you're ensuring that the number of miles is reflected correctly. Whereas if it's a out and back type of trip, you have it reflected in the proper manner, right?
Exactly.
Yeah.
Yeah. So when they list it one way, I'm going to now double the length
Correct.
because I'm assuming that you're going to walk there and back. You're probably not going to just walk one way.
And then just live there.
Which
for the
which
rest
may
of your
not be
life.
which may not be the best. Like this is just a generalized solution. This might not be the best way to approach it, but whatever. And then just do some cleanup to convert gain and high point into numeric.
Numeric. Yeah.
And then, as we saw when we looked at this Brightway Center here, there's a chunk of information listed in here. So there is a general location, so like Puget Sound and Islands, dash, more specific area in there, right? And so what I wanted to keep was this general location, so the bit before the dashes. And so that's what this regular expression is doing here, is it's going to grab the dot star is going to grab all characters up until a space, then dash, and then select the rest of the string and only keep that first bit there.
Yep.
Sorry, regular expressions, I keep on saying we need to do an episode
Yeah, they're
and
so
go really in depth because they're
like,
super powerful.
Yeah, they are super powerful, especially when you're scraping data, but they're super confusing as well. But R does make it easier with some of the string R package, like things that you could extract.
Exactly. Cool. So we've got that data set, and now we're going to actually use a very similar plot to what Henry did before. So we're going to throw in our data set. We're going to use geom_rect. We're going to set the x_min to be 0, y_min to be 0. The x_max is going to be the trail length total, and the y_max is going to be the total gain. So that basically the change in elevation for that. And then we're going to, this is for later on, label equals to name. So we're going to label each of the rectangles as the name of the trail it goes on. Setting alpha here, I'm using 0.4. You probably could have used a lower one. I'm setting the fill. So this is a forest green because a lot of hikes in Washington are rather green. And the color is brown. So it's kind of like the forestry colors that we use there. And so this will be the outline of the box. Using a facet wrap again, like Henry did, but now we're going to use this location general category that we created before. So it's going to clump them into basically the big regions of Washington and the scales. So this is important to note here. Henry set specific X and Y limits, but because these are hikes and they're highly variable in the lengths, I wanted to let each facet determine what made the most sense to show it. Because if we have, and you'll see this, there's a couple hikes that are really, really long, really long, and they drown out the short hikes.
It tends to be the really long ones are in specific regions of the state where there's room to have really long hikes. So you'd have like two of the facets that have these absurdly long hike options, and then every other facet is like, 5 miles out and back or 12 miles round trip or something like that. So it tends to be, if you're out in the Cascades where it's just like miles, hundreds of miles of hikes, there's that facet itself will drown out all other facets.
Yes, exactly. So this is what this free X is allowing me to do, is the X-axis is now going to change based on the facet.
Right.
And then we add the labels here, so setting the title to be state hikes, the X-axis is hike length in miles, the Y-axis is hike elevation gain in feet, and then just a caption going, I got this data from WTA.org, and I created this viz. So we're going to generate this, and we're going to take a quick peek at the plot. And there we have it. Like I said, I've done very little styling to this. It would look pretty nice if I were to center this, clean up the stripping, remove the back lines there, clean it up. But I think this looks pretty cool and nice. But yeah, as you're seeing before, like the Southwest Washington has
there
a
you go.
silly long hike. Like silly long. But we don't really know what that is. We will in a second. Then, like the Central Cascades, also very long hike.
Yeah.
Um,
And this is where you really want to make sure that you're aware of the free x-axis. So, like if you look at Central Washington, it looks like it has one hike that is the same length as the Central Cascades. However, if you look at the values, it's only up to like whatever that is, 35 or 40. But Central Cascades is well over 200. So you just want to make sure, in the age of bad data visualization on Twitter, just be transparent about.
Yes.
Just want to be transparent about what you're plotting on the axes.
Exactly. And then it's fun. Like you can look at Mount Rainier. There's like a trail here that's got a ton of elevation gain, but isn't super. So that might be like a tougher one because there's not as much.
Do they consider summiting Mount Rainier as a hike? Would that be it?
I don't know. We could filter. Yeah. We could filter in. Actually, let's jump to the next piece. So we're going to throw it into ggplotly. So this is we loaded Plotly earlier. So this allows us to convert our ggplot into a Plotly. One thing to note is it doesn't always do it perfectly. It does a pretty darn good job, so you don't actually have to write Plotly code, because to me Plotly code is a little bit confusing.
No, you moved the. This happens sometimes when you
rookie
move
mistake.
When you move the thing. I don't know why it does.
All right, well let's reopen.
There it is.
Reopen this puppy, and because we don't have to rerun all the data loading, we can just say, "Hey, run."
In.
So it's figuring out how to do the Plotly right now, but Plotly is pretty fun. We can talk a little bit about Plotly. Patrick, you want?
And it is kind of it's chugging because you had 1,000 hikes or it was a lot, right?
Yeah.
30 times 129. Is that what it was? 30 per page, 129 pages.
Yeah.
Yeah. So that's a lot of information that it's
a lot of data.
Plotly is so. Like Ellis said, I mean, Plotly is like, I think it's super cool, and I use it all the time. And Plotly code itself is just a little bit different to write. You have to kind of reframe your mind and how you're going to create the plots and things like that. So for those of us that are most comfortable in ggplot, Plotly makes it super easy to literally save your ggplot and then wrap it around inside of the function ggplotly. And so it took that static plot that Ellis had built and literally just makes it incredibly interactive, right? You can scroll over. I think you could actually like zoom in. So if you wanted to like zoom in on Central Washington and different pieces of Central Washington, I think actually maybe. Interesting.
So I was about to say it looks like the labels are off. It's just that they're not showing up properly.
Oh, interesting. Yeah. Let's see what happens.
See. There we go.
There they are. There. Okay.
Viewer solves everything when I'm zooming.
Yeah. Right.
But yeah, so we've got like Manistash Pass here, which is which is not a super ton of elevation gain, but it's got a 30 plus miles of length here. So what do we think this this thing down here is?
In Southwest Washington?
Southwest Washington.
300 miles?
Just under.
Just under. I don't know. What is Southwest Washington? Cascades? Is that no? The Cascades are up top.
Yeah, you could maybe it's the Pacific Crest Trail.
Okay, Pacific Crest. There you go.
Yeah,
Bridge
section
of
H.
the Gods to White Pass. That sounds like something straight out of Lord of the Rings.
Yeah, I'd imagine that this is. This is 300 miles, and so I think this is like the full. I'd have to guess it's like the full Pacific Crest Trail because I think it goes.
Yeah.
At least the section in Washington goes from like the south of the state all the way to the north of the state.
So people would walk. Well, it's like what's it called on the East Coast in the Carolinas, and you can go all the way up straight into
the
Appalachian Trail. It's like that, right?
Yeah.
It's a long haul.
Mm-hmm. Or there's this Wonderland Trail here in the Mount Rainier area. So that's the one that has a ton of elevation gain. Actually, my friend did that. She hiked for about a week, I think.
Yeah. Is that the one? I think that's the one that goes around.
I'll have to ask her the next time. But it's a really long, like, arduous hike.
And then what's the Central Cascades, the long one in the Central Cascades?
So this is also part of the Pacific Crest Trail, but this is...
Oh, wow. Okay, so that's Central... Stevens Pass to Rainy Pass. Stevens Pass, the hiking... the ski resort.
Ski resort, yeah.
Yeah.
So that's kind of fun. You can see the enchantment.
Yeah.
The enchantments are not that very long.
Super simple plot that we just turned into a fun kind of interactive with literally one line of
effort.
Code. Yeah, zero effort.
On our end, at least.
Yeah.
Lots of effort from other people.
Lots of effort from the Plotly developers, so we're super thankful for the work that they've done.
So I think that's it, though. I think we're going to call it here. This was a ton of fun to put together. I think this is just, like we said, interesting way to visualize your data where dimensions actually mean something combined. Like you want to look at that area beneath the 2 points there. It's not just a point in space.
Yeah, exactly. Yeah, super cool.
Yeah. Thank you for watching. As per usual, let us know what you're liking, what you want to see next. Put a comment down below. Email us at tidy.explain@gmail.com. Tag us on Twitter on any data viz you think is really interesting you'd like to hear us talk about in the future. Let us know whenever. We love to hear from y'all. As always, my name is Ellis Hughes. You can find me on Twitter at Ellis_Hughes.
And I'm Patrick Ward. You can find me on Twitter at OSPPatrick. And you can email us, tidy.explained@gmail.com. We love to hear from people and have ideas for our upcoming episodes.
All right. Thank you so much, and keep on exploring your world.